Lasers measure the billets on the fly, triggering diverter arms that nudge each piece into the correct lane with precise tap.
Automated shot peening for fatigue resistance. The camera peers through viewing windows into peening cabinets where fixtures rotate parts under constant streams of shot.
As the baskets move through the tunnel, high-pressure jets continuously wash and rinse the machined parts before entering the heated drying zone.
Check the thermal readings on the high spool. Crossover spike at 4 kilohertz.
I see it.
It's within the expected parameters for this sequence.
The stress fractures on the rear mount are stabilizing.
Good. Let's increase the load by 5% and monitor the titanium welds.
Cycle the ram down to the midpoint, checking pressure.
Holding steady at 500 psi. Alignment checks out.
Maintenance complete, returning unit to ready status. Reading is stable at .001.
Confirmed. Moving it to the calibrated rack.
The temperature reading on press 5 is stable now. We've corrected the deviation.
Acknowledged. Log the adjustment parameters.
Looks like we need a slight trim on the heat exchanger flow.
I see it. Turning the valve slowly now. Readings are stabilizing.
Ensure the component is seated firmly before initiating the press cycle, minimizing any hesitation during the transfer.
Drill complete. Return to stations in sequence. Prepare for cycle restart.
Adjusting the parameters for the press cycle here. Good, we've reduced the bottleneck by 15%.
We need to reroute the sponge shipment on I-85. ETA is delayed.
Copy that. Adjusting the intake slot now.
By adjusting the tensile strength here, we improve the yield. And the live feed shows the new forging temperature holds up.
This variant looks much better for the stress load.
Look at the fatigue cycles on part ID 12X. It's exceeding the model projection.
Let's run a level 3 diagnostic on that whole batch immediately.
The feedback from the floor suggests we tighten the heat treatment curve here.
Pushing the update now. Check the main display for the new tolerances.
Looks good. The robotics adjusted immediately.
The latest iteration shows improved density, but the surface finish is rough.
Okay, I'm updating the press parameters now. We should see better results on the next cycle.
If you look at the readout here, the titanium is performing exactly as projected under these conditions.
Very consistent results across the different cycles.
The materials are shaped by the hydraulic presses you see below before moving down the line to the furnace treatment phase.
This turbine blade is actually lighter than aluminum, yet much stronger.
Remarkable. I had no idea.
The line ran smooth overnight. We're at 80% capacity here.
All right, I'll take it from here. Thanks.
Your dedication to the titanium project has been outstanding. This award recognizes your hard work and innovation. Congratulations, team.
We follow the titanium from intake through melting and forging into precision machining, fit.